The exposure triangle. Why is it important and why should you know it? This is critical information for anybody doing photographs or video, especially if you're doing video here on YouTube. Just like a triangle is made up of three separate sides, the exposure triangle attempts to explain the three components to get a properly exposed negative image or video footage. The three sides are ISO, shutter speed, and aperture, or lens opening. This video is not going to be a deep dive into all of these things, but rather an overall view of what makes up the exposure triangle and how each of the sides of the triangle rely and interrelate with each other. I'm going to attempt to use a couple different metaphors to try to explain these three separate items. Let's first talk about a swimming pool. And we want to get that swimming pool filled with water. There's three things about filling this swimming pool with water. First is the size of the swimming pool. How much water is it going to take to fill it up? That is equivalent to our ISO of either our sensor or the film in the camera. The second will be the size of the hose, what we're using to fill this pool with water. Now we can use a little trickle hose and it would probably take years to fill up that swimming pool. We could use a garden hose and that's a little bit bigger around and it'll simply take a couple of days. Or we could hook up a fire hose and open that baby up and flood that pool in a very short amount of time and fill it up. That is equivalent of our aperture on our lens, or the f-stops. The third component that we've mentioned is time. How long is it going to take to fill this swimming pool? We may want to fill it in a slow amount of time, or we may want to fill it in a fast amount of time, depending on what we want to do. This quickness of the water, or maybe water pressure, would be equivalent to the shutter speed of the camera. Let's look a little closer at each of these three elements, and we're going to start with the lens aperture, or f-stop. I grabbed this vintage lens because I thought it would help show the example a little better. A lot of modern digital cameras don't actually have an aperture dial on the lens. It's all done through electronics, and the numbers can get kind of confusing because of that. So let's look at actually what's going on this lens. Right now, this lens is set to its widest aperture, which in this case is f1.7. As we close the aperture, or as we call it, stopping the lens down, as I turn this, you can see that opening getting smaller and smaller inside that lens. These are known as f-stops. The wider the f-stop, the more light is coming through, the bigger our hose to fill our pool, the ISO of our film or our sensor. The second component to the exposure triangle is shutter speed. And on this vintage Olympus OM1 camera, the shutter speeds are shown right on this dial right here. And they'll go from, actually from 1 second to a half, a quarter, an eighth, a 15th, a 30th, a 60th, a 1/25th, and so on, all the way up to 1/1000th of a second. I've opened up the back of the camera to attempt to show how this actually works. So I'm going to set this to a little slower shutter speed, like around a quarter of a second, and we're going to trip the shutter, and you'll see it open and close. Wind the film, and again, you can see the shutter open and close. If I go down to a half a second, it'll be even slower. And if I go all the way up to 1/1000th of a second, you'll hardly even see it happen. These are the three components that make up that exposure triangle. You have the aperture, lens opening, or f-stop. You have the shutter speed, or how long that sensor or film is going to be exposed to light. And then you have the ISO, which is the sensitivity of the sensor, what we've set that to. And again, that's kind of like the volume of the pool. How much can it hold? The fortunate thing as we work with this exposure triangle is all of the numbers interrelate to each other. Now again, this is not a deep dive video. This is simply trying to explain the concepts of that exposure triangle. As we look at the aperture or f-stops on a lens, this one goes from 1.7 to 2.4 to 4, 5.6, 8, 11, and 16 is the smallest opening that this lens has. Some people do find the numbers of f-stops confusing because they seem to be backwards. You would think that 16 is bigger than 2 or 4, but in reality it's smaller. And it's smaller because it's a fraction. F-stops are often displayed as F/ and then the number. That is a fraction, and it has to do with the opening of the lens in relationship to the focal length of the lens. That's a lot deeper than we need to get into in this video, but just suffice it to say, and just remember that it is a fraction. So f16 is smaller than f8. Each of these numbers on the aperture dial represents half or twice the amount of light as the one prior. So for instance, f2.8 lets in twice as much light as f4. f4 lets in twice as much light as f5.6, and so on through f8, 11, and 16. On our camera, the shutter speeds do the same thing, but the relationship of the numbers seems to make a little more sense, where you have a 15th of a second, but if I go to a 30th of a second, that's letting in half as much light. And I go to a 60th of a second, again, that is half as much light as a 30th. 125th, again, half as much light as the 60th. 250, 500, 1000. Then we also have the ISO of our sensor. This is a vintage camera from the 1970s, and we didn't call it ISO back then. We called it ASA. It was the American Standards Association, ASA, as opposed to the international standard. It is set up on this camera in 1/3 increments, so that gets a little more confusing. But if we look at the whole numbers, it kind of makes sense. So if we have 100 ISO, and then we go to a 200 ISO, that makes the sensor twice as sensitive, or it'll only take half the amount of light to create the proper exposure. Then we can go to ISO 400, and again, it only takes half the amount of light for that proper exposure. Each of these things are either double or half of each other. So therefore, when we know a proper exposure and then we want to make some adjustments for an artistic reason, it's very easy to choose the one that we want to set in stone, and then adjust the other two sides of that triangle so that everything meshes. Let's look at how these things all interrelate and how we can change what we need to change. If we have our ISO, let's say we have it at 400, and a proper exposure is going to be a 60th of a second at f4. But we have fast moving things going by, so we want to set that shutter speed a little faster to help freeze that motion. So I can go 2 f-stops, 125th and a 250th. Now I've got a little faster shutter speed, more likely to freeze that action, but I'm going to be underexposed because I'm not letting in enough light. So I need to expand the size of our garden hose to fill that pool a little quicker. So I move 2 f-stops there, 60, click, 125, second click, 250. So let's open up 2 f-stops from f4 to 2.8 to 1.8. Now I should have the proper exposure because I've changed both my shutter speed and my aperture by 2 f-stops. On a film camera, we had to load a roll of film in and our ASA or ISO was set. That's what that film was. But with a digital camera, you can change that ISO rating or the sensitivity of that sensor on the fly, which is really pretty amazing. Let's say my proper exposure is f16, which is a very small lens opening, letting in very little amount of light, and then a 500th of a second, that's a very fast shutter speed, it's letting in very, very little amount of light, and my ISO is at 400 for all these things to happen. With a digital camera, I can adjust that ISO and I can lower it down. So if instead of 400, let's say my camera lets me go to 100. That's 2 f-stops. So I can set my ISO from 400 to 100, Let's get that set right there. So we're set to 100 on this. Then I can move again to f-stops. So I can either open up my lens 2 stops from 16 to 11 to 8, and I have the proper exposure, or I can leave it at 16 and I can open up to a 250th and 125th. Again, that's 2 f-stops. And again, I have the proper exposure to create the lights and darks and the tones necessary to have a properly exposed image. But Jim, you ask, what is a proper exposure and how does the camera determine that, or how do we determine that? That is an excellent question, and I've got a video right here that explains how light meters work and what it means to have a proper exposure. What does 18% reflectance gray actually mean? I'm James Fisher, this is Vintage Insight Photography, and remember to stay focused.